So now we are going to see the 10th topic, that is double integration in Cartesian and polar form, right? So first let us start with Cartesian, then we will move on to the polar form. So double integration. Let f of x comma y be a single valued function and continuous in a region R bounded by a closed curve C. Let the region R be divided into subintervals R1, R2, etc. Rn of areas A1, A2, etc. An. Let xi comma yi be any point in the subregion Ri. So now consider the sum, summation I is equal to 1 to n xi comma yi into ai. The limit of the sum as n tending to infinity in such a way that each ai tends to 0 is defined as the double integral of f of x comma y, that is, it is given by limit n tending to infinity summation xi comma yi into ai is equivalent to double integral over the region R f of x comma y into dA. So this can also be done as double integral over R f of x comma y dx dy or double integral over R f of x comma y dy dx. Right? Okay. So let us start with the problem here. Now we are going to evaluate double integral 0 to 1 and integral 2 to 3 x square plus y square dx dy. Here both the limits are constant limits, right? So here both the limits are constant limits. Here we call this as, so here you are going to have integral 0 to 1 and the inner integral is 2 to 3 x square plus y square dx dy. So first let us evaluate the inner integral. So we are going to integrate first the inner integral, then finally whatever the answer you are going to get, that we are going to integrate with respect to dy. This we call it as a iterated integral. So now we are going to integrate this inner integral with respect to dx, treating y as a constant. So this is equivalent to integral 0 to 1. So here first term is x square. So when you integrate, you have the formula for integration x power n dx. Integral x power n dx is given by x power n plus 1 divided by n plus 1. Therefore, x square will be done as x cube divided by 3 plus y will be treated as a constant. So y square will remain as it is, and for dx it is x over the limit 2 to 3. So when you apply the limits, you will be applying it as upper limit minus lower limit. So when you apply the upper limit, this will be equivalent to 3 cube by 3. So you can cancel out 1 3 and you will be getting it as 3 square, which is nothing but 9, and plus y square into 3. So this is the upper limit. Then similarly, you are going to apply the lower limit. So minus of lower limit, that is 2 cube divided by 3 plus y square into 2. Okay. Finally, we are going to integrate this with respect to dy. So this is equivalent to integral 0 to 1 9 plus 3y square, and 2 cube is 8. So this is minus 8 by 3 plus into minus will become minus 2y square into dy. Let us simplify this. So here you are going to get 9 minus 8 by 3. When you take the LCM, it is 27 minus 8 divided by 3. 27 minus 8 will give you 19 divided by 3. So this is equivalent to integral 0 to 1 19 by 3. When you combine these two terms, that is 3y square minus 2y square will give you plus y square. Now we will integrate this with respect to y. So this will be 19 by 3y. For y square, it will be y cube divided by 3 over the limit 0 to 1. When you apply the upper limit, this will be 19 minus 3 plus 1 by 3. When you apply the lower limit, this is going to become 0. So when you simplify this, 19 plus 1 will be 20 divided by 3. So this is the answer for the first problem. Okay. So similarly, we will move on to the next problem where we are going to see the variable limit. See here, the inner integral is having variable limit as x square to root x and the outer integral is 0 to 1. So whenever we are going to deal with the variable limit, always the inner integral should have the variable limit, and finally you are supposed to substitute the constant limit. Okay. So let us write this as integral 0 to 1. Here the inner integral is integral x square to root x y into dy into dx. So when you integrate this, this is going to give you y square divided by 2 over the limit x square to root x into dx. So this is, let us take 1 by 2 common, it is a constant, let us take it outside the integral. So this is integral 0 to 1. When you apply the upper limit, it is root x the whole square. So what is root x the whole square? This is going to be x. So this is x minus, and lower limit the whole square, that is x square the whole square will give you x power 4 into dx. So this is equivalent to 1 by 2 times of, for x it is x square by 2 and for x power 4 it is x power 5 divided by 5 over the limit 0 to 1. So when you apply the limits, this will be equivalent to 1 by 2 minus 1 by 5. When you apply the lower limit, it will give you 0. So we need not bother. So let us take the LCM now. So this is 1 by 2 times of 5 minus 2 divided by 10. So this is equivalent to 3 divided by 2 times 10 will give you 20. So the answer for this problem is 3 divided by 20, right? So now let us see the double integration in polar coordinates. So whenever we say polar coordinates, you all remember about r and theta, right? So this is nothing but double integral theta 1 to theta 2, r1 to r2, f of r comma theta dr into d theta. So let us start with the problem here. Let us evaluate integral 0 to pi, integral 0 to a, that is double integral 0 to pi and 0 to a r dr d theta. So the inner integral is with respect to r and the limit for r is 0 to a and the limit for theta is 0 to pi. So this is equivalent to integral 0 to pi times of integral 0 to a r dr. So first evaluate the inner integral, then finally you will move on to the outer integral. So when you integrate r with respect to dr, it is r square divided by r. So this is integral 0 to pi. For r, it is r square divided by 2 over the limit 0 to a d theta. When you apply the limit, this will give you integral 0 to pi a square by 2 minus 0 into d theta. So a square by 2 is a constant. So this is equivalent to, let me write it here. Let me take this a square by 2 outside the integral. The remaining is integral 0 to pi d theta. So integral d theta is nothing but theta. So this is a square by 2 times theta over the limit 0 to pi. So let us apply the limits now. So this is a square by 2. When you apply the upper limit, it is pi, lower limit is 0. Therefore the final answer will be pi into a square divided by 2. So the answer for this problem is pi a square divided by 2. Next we will move on to the next problem. So we are going to evaluate integral, double integral 0 to pi and 0 to a cos theta r sin theta dr d theta. So this is nothing but, so here it is integral 0 to pi and here it is integral 0 to a cos theta r sin theta dr d theta. So now in the inner integral, it is a combination of r as well as sin theta, and we are going to integrate this with respect to the variable r and treating theta as a constant. So this is integral 0 to pi, sin theta will remain as it is. For r, it is r square divided by 2 over the limit 0 to a cos theta d theta. So this is equivalent to 1 by 2 times of integral 0 to pi sin theta into, for r it is a cos theta the whole square. So this is a square cos square theta d theta. So let us take a square outside. So this will be a square divided by 2 integral 0 to pi sin theta into cos square theta d theta. So we all know that differentiation of cos theta is equivalent to minus sin theta d theta. So we are just going to introduce a negative sign here. So this will be minus a square by 2 integral 0 to pi cos square theta into differentiation of cos theta. So now we can easily apply the formula integral x bar n dx, which is equivalent to x bar n plus 1 divided by n plus 1. So now this is equivalent to minus a square by 2. We already have integral 0 to pi cos square theta differentiation of cos theta. So instead of this, we can apply the concept of x power n. So this will become cos cube theta divided by 3 over the limit 0 to pi. So this is nothing but minus a square by 2 3s are 6. So the remaining will be cos cube pi upper limit minus lower limit. Okay. So what is the value of cos pi? The value of cos pi is minus 1 and the value of cos 0 is plus 1. So this is equivalent to minus a square by 6 times of, for cos pi it is minus 1, therefore it is minus 1 the whole cube, minus for cos 0 it is plus 1. So this is nothing but minus a square by 6 times of minus 1 minus 1. So this will give you minus 2. So minus 2 into minus will give you plus, therefore the answer is nothing but plus 2a square divided by 6. You can cancel out 2. Therefore, this will give you the answer as a square divided by 3. So, this is the answer for this problem, right? So we will stop with this. We will move on to the next lecture in the next topic. Okay, thank you.